Okay, back again with some examples. This will probably be a little bit quicker here of polynomials or finding derivatives of functions that are polynomials. And essentially, we're using the three theorems that you can see here. The derivative of a constant function is just zero. The derivative of a power function, basically what you do is take the exponent down in front and subtract one from the exponent, and you're good to go. And then if you have multiple terms, if you look at a polynomial as a sum of, like, for instance, this one of four functions, this first function, x cubed, the next function, negative x cubed over 16, and so on. What you do is you just take the derivative term by term and then add them up. All right, so this will be our first example here. And by the way, you can use pause and scroll again as needed, but I'm trying to keep this short. So essentially, I'm going to go through and I'm going to take the derivative of each term. Now, this again eliminates the need for me to go ahead and use that big old definition with the limit is of f of x plus h minus f of x all over h, and take that limit as h approaches zero. You don't need to do that. All you need to do is quickly, I demonstrated that last video, is just take the 3 down front, subtract 1. Get 2, take the 2 down front, so you'd actually have 2/16, which reduces to 1/8. You can write that out if you want. I didn't feel necessary to do that, and then subtract 1 from 2, and you get first power. 1 minus 1 is a 0 power, so that's just going to be x to the 0 or 1, so the derivative is 4, and then the derivative of the 6, again, using that as a constant, is a 0. So essentially, that's how we find y prime in this case, and that's the notation we're using. Let's go on to example 2. Same deal. If you have negative exponents like we do here, notice they use the dy dx notation. So y prime and dy dx mean the same thing. So I'm going to take the 2 times 7 and get 14. Again, you have the first power, so that's going to give you 0 power. Just you're essentially going to be left with the coefficient, constant term here. And then if I take -2 times -4, I get 8. Subtract 1. You just got to be careful using the negative exponents. So -2 minus 1 is actually -3. You may want to express this term as 8 divided by x cubed, but I think my math lab takes it either way. Going a little bit out of order here, I forgot to do number 3 when I was writing up these examples. So I guess I can do number 3 here. The thing you want to do is take the function here. Notice I just put an equal sign. I'm rewriting it. I'm using my basic laws of exponents from Algebra 1. And so I could take this up to the numerator. So that would make that x to the 3rd power. Since this is x to the 1st, I take that up to the numerator, negate the sign, and I get -1. So now I'll take the derivative term by term. So here we go. -3 times 6 gives me -18. Subtract 1, I get -4. -1 times -6 gives me +6. Subtract 1, I get 2. And like I said, you can convert those back to positive exponents. But I think my math lab will take either this one here or this one over here. And I noticed I forgot my negative there. So excuse me for that. That should be a negative right there. Okay. Apologize for that. Let's move on to number 4. Okay, so we go to number 4, and again, I'm just going to rewrite this first of all. Remember, converting from radical, this is notation to exponential or rational exponents. This is the first power, and you convert that to whatever power this is. In this case, is first power divided by the root. So the cube root of x is just the same thing as x to the 1/3, and then I go ahead and write that now as a negative exponent. So I take the -1/3 times -7, I get a +7/3. Subtract 3/3, right? Because 3/3 is just 1. Subtract 3/3 from 1/3, and you get -4/3. Okay. Moving on to number 5. Number 5, this one's kind of a little bit of a, I don't want to say a trick, but it kind of is. We're going to learn the quotient rule later. You can use the quotient rule, but it's a lot harder than using this technique here. All we're going to do is just break this up. Okay, and what I mean by break it up, we're usually used to getting a common denominator like x over here and then combining the numerators. Well, now we're just going to split it up over the same common denominator. And when we do that, this simplifies to 3x squared. This simplifies to x to the negative first power. Now I can take the derivative. I'm going to take 2 times 3 and get 6. Subtract 1, I get x to the first power. Take negative 1 times positive 7, I get negative 7. Subtract 1 there, you get negative 2. And there I just chose to write it with a positive exponent. The last thing we want to do here, I know I'm going quick, is we want to find the slope of the tangent line to the graph of the given function of x, okay? And the slope of that tangent line to that graph is, okay, and then we're just going to write that in there. Now, I went a step further just to show you here without going over another example. They're not asking you to do this, but find the equation of the tangent line. But just again to emphasize the fact, I wrote the function using f of x notation. Here you can see I just got it over here. And now I'm going to take the 1/2 time to find the derivative. 1/2 times negative 9, I get negative 9 halves. 1/2 minus 2 halves gives me a negative 1/2. Same thing here. I take the 3 halves out front, subtract 2 halves from this. That leaves me with positive 1/2. And I just simplified here. Instead of writing that to x to the 1/2 power in the denominator, I just put the square root of x. And the same thing over here. Instead of writing it as x to the 1/2, I just wrote that as square root of x. They gave you a convenient number here now because what I need to do is find the slope of the tangent. Once I find the derivative is just plug in the 9. Remember, if you want the slope of the tangent at 2, you just plug in a 2. If you want the slope of the tangent at 7, you plug in a 7. They're asking us to find it at 9. So I plug in a 9 for x. I get the following. By putting the 9 in. Square root of 9, like I said, is a convenient value, is just 3. So that's why I get 3 times 3 here, and I get 2 times 3 here. So that gives me 6, right, in the denominator, but negative 9 over 6 reduces to negative 3 halves. So I have negative 3 halves plus 9 halves, and that gives me 6 halves, which is the same as 3. So you can key all this in your calculator if you want. You're still going to get 3. Then I use the point slope form, okay, because I took the original function, right, to find the y-coordinate. So if I just plug in the 9, I simplify all this, I get 0. So when x is equal to 9 in the original function, the y is equal to 0. So now I'm just using point slope form. I take y minus 0. I take my slope of my tangent line, which I found over here, f prime of 9 is 3. And then I write x minus 9. I simplify that to the best of my ability, which is basically just distributing this through, and I get 3x minus 27. And there is my equation of my line. So I know that's pretty quick there, but you know, like I said, not too bad with the algebra is concerned. And there you have it, derivatives of polynomials using your power rule and the sum and difference rule. All right, we'll see you next video.